Yes, madam. Now you are good to go.
Good morning, everyone. Welcome to the final day of our 5-day international short-term training program on recent advancements of fuel cells and hydrogen storage. It's been an incredible journey. Before we dive into today's session, let's take a moment to recap what we have covered so far. Over the past 4 days, we have explored a wide range of topics from high-temperature fuel cells, electrochemistry basics, thermodynamics of fuel cells, sessions on FCHS, material for hydrogen storage system, future of green hydrogen in road transport by eminent speakers. We hope you have had these sessions insightful and valuable for your personal and professional life. We'd like to express our gratitude to all of you for your active participation, engagement, and dedication to this training. It's your enthusiasm and commitment that has made this training a success. In today's session, we have our guest, Dr. Anil Kumar Sir, Associate Professor, Department of Mechanical Engineering, Delhi Technological University. Sir is going to discuss on the topic, application of solar energy in hydrogen production. It is my privilege to introduce our guest, Dr. Anil Kumar Sir. Dr. Anil Kumar is Associate Professor in Department of Mechanical Engineering with an additional charge of Additional Coordinator, Center for Energy and Environment, Delhi Technological University, Delhi, India. He has completed his PhD in solar energy from Center for Energy Studies, Indian Institute of Technology, Delhi, India in year 2007. He was postdoctoral researcher at Energy Technological Research Center, Department of Mechanical Engineering, Faculty of Engineering, Prince of Songla University, Hatay. He worked as Assistant Professor, Department of Energy, Maulana Azad National Institute of Technology, Bhopal, and also in Department of Mechanical Engineering, Rajiv Gandhi Pradyogiki Vishwavidyalaya. He has published 2 patents, 125 journal articles, 19 book chapters, 34 conference proceedings, 35 review papers, 3 book chapters. He has investigated 6 research projects funded by government bodies. He has guided 10 doctoral theses. He is a member of 8 professional bodies and member in 11 technical and non-technical committees or boards. He has won several awards like Outstanding Scientist Award, Distinguished Scientist Award, Commendable Research Award, Research Excellence Award, Outstanding Researcher Award, Best Paper Award. He is an active reviewer and appreciated for his outstanding service in the Reviewers Committee of reputed journals like Elsevier. He is featured at most cited information systems researchers in the world ranking of top 2% scientists in 2020 and expert first So Young Scientist Conclave on shaping SEO style partnership, Young Scientist Perspectives. He was the guest of honor National Conference on Futuristic Trends in Mechanical Engineering held from 22nd to 23rd November 2019. He also worked as observer in JEE Mains, advisor member, Anchor Institute in Solar Energy 2017, India. He was selected under the scheme of Early Faculty Induction Program 2004. He secured Senior Research Fellowship Award for pursuing PhD in 2001 from Indian Institute of Technology, Delhi. We are eager to learn from your expertise, sir. Sir is not muted.
Sir, I think you have to unmute, sir. Anil, sir?
Yes. Sorry. Namaskar. Thank you very much, madam, for such a nice introduction. And,
Namaste, sir.
Namaste. And namaste to all of you. And I'm very much thankful to all the organizing committee members for inviting me for this talk on the solar energy application on production of hydrogen in this recent advances in fuel cell and hydrogen production from 9 to 13. Today is the last day, and I'm thankful to a head of the department, chairperson of Anurag University, uh, uh, this, and vice chancellor, and all, in fact, all the coordinators for organizing such a nice program. And this is the last day, and many things have already been covered. So let me start sharing my screen. I hope it is visible.
Yes, sir. It is visible. Visible.
Yeah. Okay. Now, yes. Okay. So, coordinators have given me responsibility to cover this topic, the solar energy in hydrogen production. And before that, I know most of the fundamental have already covered. So I would a little bit talk about 60 minutes. Dr. Vishwanath, you have given me 60 minutes now, right?
Yes, yes, sir. Yes, sir. Yes, sir.
Okay. Okay. So in within 60 minutes, I would like to try to cover some basic things, and some technology involved. In fact, the technology of solar energy involved in the hydrogen production. Right?
Yes, yes.
Okay. So well, I would like to cover history. It's a brief history of the hydrogen, how hydrogen is safe, hydrogen demand, hydrogen costs. In briefly, I know most of the things I have already covered in the last 5 days. Okay, this is the last day, and in fact, this is my talk in the last of this short-term training program. So, objective of solar hydrogen production, then solar hydrogen production method, opportunity for India in green hydrogen in India government initiative, and technological advancement. There are some, I have included some case study also. So I'm not sure whether I will be able to complete within the 60 minutes this all. So basically the hydrogen production and the development, whatever the development is there from the last 2 century only. In 16th century, the Paracelsus from the Switzerland discovered this gas was formed between the sulfuric acid and iron, right? In Merlin from Switzerland in 17th century, she observed the gas is burned. In 1761, the Robert Walsh produced the hydrogen reacting from the iron fields and the dilute as metal and acid reaction. Further, in 1706, the Henry Canvis identified hydrogen is a unique substance and placed in our this table, this chemical table, right? In 1786, the internal laborers produced the hydrogen, and then 1788, he named the material hydrogen, and this is the Greek word, the hydrogen. And further, the English scientist Nicholas and Charles used the first time the electrolysis of the water. Right, this was the breakthrough. So further in 1839, the British scientist William Robert Broke developed the hydrogen power cell, and like this was so far this hydrogen production side. But regarding this application point of view, the Count Ferdinand of Germany, he's from Germany. He used the hydrogen as in balloon. The first balloon was in the 1900 that used the hydrogen to maintain the buoyancy of the airframe. So airship to cross the Atlantic were put into service during 1920 and 30. In NASA also, they were first time applied, means application of the hydrogen energy was done in the 1950, 58 to pursue the space exploration and made the great historical contribution to hydrogen use. And in fact, it was the world's largest liquid hydrogen user by the time in the 1961. The first space was launched in the 1981 by the Soviet Union. By the time the Soviet Union combined, all the country was there. Okay, so complete their flight. PU-155 were the first jet engine aircraft that used the liquid hydrogen in 1988. So people are using hydrogen from the long back, and in fact now because of the crisis of this fossil fuel, at the same time the environmental degradation. So they are attracting towards the renewable energy source. In fact, the renewable energy source and the hydrogen, as we know, the hydrogen is one of the fuel which is having the highest calorific value, around the 120 142 megajoule per kg, right? So and there some accidents were occurred at the same time. The hydrogen means people just thinking this is a synonyms of hydro danger. So its extremely flammability nature, especially in the Hindenburg disaster in the 1937, almost 35 passenger out of 97 were killed in this airship. So because people have some fear of regarding the utilization of the hydrogen. Of course, it is very highly flammable, and but at the same time, it has some good quality also. It is very dispersive as compared to the other fuel. So these were the Hindenburg while on the fire, break, airship, Roma. So like this, these are the some accidents occur, right? So uh, so how does it say? As we know, it is non-toxic and much lighter, or it is very dispersive. It dissipates rapidly when it releases, allowing the relatively rapid dispersal of fuel in case of the leak, make it relatively safer than the other split fuel. Primary safety concern is about the leakage and undetected or the gas collected in the confined space. It can eventually the ignite and cause the explosion. If suppose space is confined, then only it is having some problem because of the explosion, right? So is some through a thorough understanding of the hydrogen property and designing safety feature. Now actually the more and more hydrogen application is there. So that fear has come out. Actually, people are taking initiative for the development of the hydrogen fuel based applications, right? So in that, only the training is on will only only make sure us for the using the hydrogen as a fuel. So training in the safe hydrogen storing and handling practices are the key element for ensuring the safe use of hydrogen. So as per the US Department stated, like as more and more hydrogen demonstration get underway, hydrogen safety report can grow and build confidence. Actually, by using only we can develop our confidence regarding the hydrogen. It can be safe and fuel, right? So just look at over here, its application in hydrogen is basically almost whatever the hydrogen is developed, it out in that 51% or out of that 51% is used for the production of ammonia and methanol fuel, then oil refinery and other applications, right? And in ammonia is having a lot of application, industrial application, and one of the most important application of ammonia is fertilizer. Okay, uh, right. So so in that this hydrogen demand basically, so it increase hydrogen demand increasing every year, and being widely ammonia is produced 51, oil refining 31%, and methane production 10%, remaining 8% other uses, right? So recently most of the developed country are using hydrogen as a transportation fuel, and in India also the IUCL have taken this initiative. The hydrogen one passenger vehicle is running based on the hydrogen fuel only. The S2 is being the fuel cell to S2 is being used as a fuel cell for to generate the electricity and water vapor as a. However, this in the low capacity, the water vapor will immediately disperse. But in the large scale, we can have one byproduct of the water itself, like for the production of the biodiesel, we have glycerin is a byproduct over there, and glycerin has many applications. The similar way, the water problem can be solved in the large scale application of this hydrogen fuel cell. So considering the future need and the demand of H2 is important to find and basically over here, okay. So our main aim is to find the route where the reduction of the production cost is there, right? So just this is so hydrogen is basically produced from natural gas. The 48% is responsible for the natural gas only. The oil 30%, and coal is 18%, and the water is 4%. And just look at over here the how the global energy consumption is increasing day by day from 19. This is relatively old picture. However, the some but trend is almost same. So from 1980 to 2030 is up to 2014. After 2014, the projection is over there. Okay, so means global energy demand keeps on increasing because of lot of infrastructure development all over the world, and especially in the developing country. Okay, so more and more industrialization and regarding in transportation, for easy of the transportation facility, and in as far as means more and more energy consumption, it means in any country the prosperity of the country is there. Per capita energy consumption is increasing. That means the prosperity, it directly reflects the prosperity of that particular country, right? So in coming time, definitely we have our energy consumption will and demand of energy consumption will increase definitely. And we have limited resource. Fossil fuel have very limited resource. We have at the same time it degrade the environment. So we have to find out some other solutions. Renewable energy now almost lot of work have already been done on the renewable energy and quite mature. All the technology are quite mature. Whether this is solar, wind, biomass, or other kind of the technology, they have fully developed. Okay, so those renewable energy uh, we can use for the production of the hydrogen, right? So electricity produced from nuclear energy, or say nuclear energy, right, or solar photovoltaic, hydrogen, so hydropower, wind power. So that is that electricity we can use for the electrolysis process for the production of hydrogen, and other forms of the renewable energy, solar thermal for the hydrolysis process, the thermal cracking that we can do with the help of solar thermal. Biomass is another very promising raw material. You can say raw material for production of the hydrogen. And biomass, in biomass energy conversion, one anaerobic and aerobic is process for production of the biomass, biogas, where the methane is the main constituent of this biogas, right? So methane, we can convert the methane into the hydrogen, and we can extract the hydrogen from the methane itself, or with the help of these energy sources. And another method is the gasification also, right? So there the CO and S2 is the main constituent. So there the S2 we can extract from that syngas, or the gas in the gasification process. Okay, so natural gas, of course, we are using a natural gas as the more than the 40% of the natural gas is being used for the production of hydrogen. And coal, however, this coal is relatively costly technology. So means these all energy source we can use for the hydrogen production, and for the different application, industrial application, building application, and transportation fuel, in industry, the turbine or IC engine for the power production, process synthesization, and poly generation, right? So in the industry, the various application we have the hydrogen. The tertiary residential commercial building, we can use the fuel cell. We can use the fuel cell for the electricity production, electricity generation. Okay, and the fuel cell energy, and this hydrogen we can use for the transportation purpose, as in the form of the fuel cell based engines, or IC engine also. IC engine, the modified IC engines we can use for the hydrogen. We can use the hydrogen as a fuel for the modified hydrogen, this IC engines, right? So as we know, the global energy system, S2 will play the key role in the shifting the global energy system toward the sustainable energy system by the 2050. The Hydrogen Council they have documented that hydrogen energy has been grown drastically in the form in 2020, and it has the potential to unlock the 8% of the 8% of the global energy demand with the production of 2.5%. However, and this is our prediction basically, and in fact, the cost of production of hydrogen is varies from zero point 0.8 to 4 per, zero point 0.8 to 4 US dollar per kg, and right, and worldwide it varies from this value. And by 2030, the hydrogen production cost is expected to reduce the 1.8 USD, and it can unlock up to the from 15% from the 8% of the global energy demand. And cost of that varies. Just look at over here. This is basically the cost of hydrogen in the different region, right? So in all the region like this America, North, this Europe, Africa, they are classified basically the southern, eastern, central, western, and northern part of these continents, right? Just see over there. The lowest means power, this hydrogen generation cost is lowest is somewhere in zero point 0.8, right, yeah, over here in this the South America it is zero point 0.8. Okay, point it varies over there in South America, 0.8 to 3.6 USD per kg right now, right? So in this way, it is means worldwide, the hydrogen production is taking place in worldwide. Or scientists are very keen to develop the scientists this hydrogen production at lower cost, whatever is possible, right? So now just look at over here. The major hydrogen consumption is in the South Asia portion, and over there this European country. European is first highest S2 consumption is over there in this Europe, then this Asia, then this America, then Africa, then Australia, right? And further in Asia and Europe, we can split in the eastern, western, southern, and northern, and west central part, like in this way, right? So means this variation in the cost of production of the hydrogen is based on the availability of raw material in that area, and the labor cost. Many costs are affected basically. Just you can see over there, these are the parameters involved in the cost analysis: the operational cost, cash flow, hurdle metrics, then the total capital investment, direct indirect cost is there, direct indirect capital cost and equipment cost. In under direct cost, the instrumentation, control, pipeline, electrical energy, building, the installation factor. In the under indirect engineering and supervision, construction, legal expenses, contractor, contingency, the equipment cost, design, transportation, installation. These are ultimately our aim is to reduce the hydrogen production cost and plant profitability and competitive economics, right? So this is our ultimate aim. Okay, and now you just see over here. So this is the importance of hydrogen in participation in various energy sector. Just hydrogen is globally applied due to the production that can perform the using the feedstock, right? And so means feedstock. In fact, for the steam reforming process, we need the feedstock. In coming slide, I will discuss about this. The hydrogen is a main chain between the hydrogen consuming industry. For example, ammonia, ethanol, ammonia production, ethanol for the fuel production plant, and the other central industry like electricity, grid, transportation, agriculture, energy. These are the different applications. Consequently, the numerous production choice, the hydrogen could when the addition of the flexible and sector-wise energy system. So just look at over here, the in renewable energy चलिए भाई, Am I audible? अभी?
Your voice is breaking.
Am I audible?
Your voice.
Am I
Now
audible?
it's clear. Now it's clear, sir.
Yeah, it is clear, sir. Clear.
Am I audible? Dr.
Yes,
Vishnu,
sir. Yes, sir.
am I
Audible,
audible?
sir. Audible, sir.
Yeah,
Yes, sir. Audible.
very sorry. Very sorry, I was disconnected.
No, no issue, sir. Please. Hello.
अच्छा लड़का जो मानो मेरे को इंटरनेट से कनेक्ट ना be produced relate with the sources nuclear mass including this we can so I find this produce the form of the hydrogen methane in terms of the fuel that is for our fuel. देखना ये चला के चला ये चल गया so this is method chemical storage classified as a compressed and नहीं चल रहा ना नेट चल रहा है
अभी चल रहा है सर. चल रहा है सर. चल रहा है सर.
अभी थोड़ा बीच में प्रॉब्लम होता है.
जी सर जी एक मिनट
सर.
एक मिनट
अभी थोड़ा स्क्रीन शेयर नहीं हुआ अभी शायद.
ओके ओके जस्ट अ मिनट
वायर इंटरनेट में थोड़ा प्रॉब्लम था.
हाँ नहीं हमारे भी थोड़ा यहाँ पे भी हुआ था थोड़ा वो. अभी ठीक हो गया. आ रहा है सर. आ रहा है.
आगे सर
हाँ आ गया. आगे स्क्रीन आ गया.
ओके
hydrogen storage
You're
method,
not
sir.
audible, sir.
Yes,
It's
yes.
breaking.
Yes.
Sir.
Sorry. Yeah. So in this hydrogen storage, the physical storage, chemical storage, that further we can classify the compressed hydrogen storage, liquid hydrogen storage, and cryo compressed hydrogen storage. And in regarding this chemical storage, metal hydride, chemical hydride, and absorbent. Okay. Now just look at over here, like this. This the cost, basically cost in the hydrogen storage and cost in transportation and cost in reduce in fueling station, basically. Okay. uh, Fueling station, just the compressed gas storage, liquid gas, liquid hydrogen storage, and metal hydride. The cost of the storage is least in the compressed cost of in the least in the compressed gas storage only. The cost of the transportation is least in liquid hydrogen. As we know, the liquid transportation is always easier, right? And the cost of this fueling station is in almost same, means 30 or 37 rupees per kg of the hydrogen, right? So main issue with the hydrogen transportation is hydrogen is a very highly combustible gas and very low volumetric density, that makes it difficult to store even a small quantity of the liquid, this quantity of the hydrogen. And liquid and compressed storage are widely used in the store hydrogen in large scale. And in fact, the liquefaction of the hydrogen requires a significant energy input, as its boiling point is very low, minus 23 or 25 253 degrees centigrade. And but the hydrogen provides the comparatively very high storage density. The liquefaction consumes 30% of the hydrogen. So means, and there are some risk and security issues also. So hydrogen is better, is having the better coefficient of diffusion and a lower density, much safer than the different as known fuels. Okay. So in addition, the is high specific heat of H2 efficiently reduce the increasing temperature in order to certain heat input. And gaseous fuel having very light density, it's only 6.9% of the air density. So this is more dispersive as compared to air, and therefore gas is quickly diffused in the developed from its source, and lower the risk is over there. Only if suppose confined space is there, then only it is much more danger. Okay, otherwise dispersive, it is very dispersive. So this is means good quality, means safer side, we can say. The leak of hydrogen is not responsible for damage. This is another thing, because in climatic condition, damage of the climatic condition or adverse climatic condition, this is non-toxic nature, and this is not responsible for any climate degradation. Leakage is there. So only explosiveness is definitely it is a major concern. So additional security benefit of S2 is connected accompanied with a clean flame and cannot scorch skin from the distance. The main issue caused by the flame is the emitted small thermal radiation in absence of the soot material, right? So if suppose kerosene we burn or some other kind of the fuel is one, by the soot is there, and in fact the diesel is there, the soot formation in diesel is a major problem with the soot formation, right? So S2 can also safely carry in the pipelines how the hydrogen burned, okay, in the safety purpose. So why we want to use the solar energy for the hydrogen production? So as we know, there is overburden on the fossil fuel, and due to the more utility of fossil fuel, and of course it will decline. It will decline over a few years. The renewable energy sources are completely developed and accompanied by the advancement of its production method and contained sustainability. So renewable energy source means conversion technology of the renewable source into the useful energy is now very mature technology. Whatever the solar, wind, biomass, in solar, the solar thermal, solar photovoltaic, these are very mature technology. So that electricity generate, or in fact directly the heat energy from a sun, we can use for the H2 production, and it is means there is no any harm to the environment. It is totally environmental friendly. Production of the hydrogen using solar energy is very protecting to the environment. No greenhouse gas is generated during the operation. However, during manufacturing of solar energy conversion device, whether this is a solar photovoltaic system or the solar thermal energy conversion systems, during its fabrication, definitely it is definitely it is it produces some greenhouse gases during the fabrication, right? So so means another factor is efficiency of first, the efficiency of the solar energy into the electricity is still very low. And regarding solar photovoltaic system, on an average, its efficiency is not more than 11 10 to 11% in real situation. However, uh, energy conversion efficiency of photovoltaic system in the lab scale level, it has been claimed like the 41%, 42% in some research lab. In during research lab and in very controlled environment, it is possible, but in actual environmental condition, to achieve the 15%, even the 15% of the energy conversion for the solar photovoltaic system is very a good thing, right? So, and at the same time, the solar thermal system, of course, there in hydrogen production, we need the very high temperature. There, this flat plate collector or evaporative collector or the silver energy conversion device, which are producing temperature lesser than 200 degrees centigrade, are not much effective. We need the high temperature, in fact. So solar CSP systems are required over there. Solar CSP system, solar parabolic tuff collector, parabolic dish, heliostatic type, solar mirror, tower type systems. So basically, these systems having the higher concentration ratio. Higher concentration ratio means we can produce the higher temperature, right? So there itself, efficiency, if suppose we say the efficiency of conversion efficiency of the solar radiation into the heat, that is much higher as compared to the electricity conversion, right? So another important factor is the exergy efficiency, and of course our interest is in exergy efficiency only. So actual useful energy we want to see and in fact our interest is to enhance the exergy efficiency. So exergy efficiency of the photovoltaic generator, hence overall efficiency of generator is currently challenging for the researcher, and we have to identify in which area we can enhance the exergy efficiency. Okay. Of course, for utilization, or in fact for solar radiation, solar radiation, electromagnetic waves are there, and the conversion of electromagnetic waves to electricity, either electricity, these are the two routes, electricity and the solar thermal. So whatever the route is there, we have to enhance its exergy efficiency, right? Then and one more thing, so maximum solar production is generated by the 99% with the natural gas and fossil fuel that we have already seen over there in the previous slide. The rate of hydrogen production is nearly 50 million tons globally, that is denotes only 2% of the energy demand. The cost of hydrogen production from the various production is still high, and cost of the $2 USD per kg as a coal gasification, and $7 US per kg hydrogen production is for the basically this $7 USD is for solar hydrogen through the solar photovoltaic or the water electrolysis process. What we are doing over there, we are utilizing the solar electricity into the electrolysis process. Okay, so we can have the hope it will reduce. It can be reduced up to the 1.4 USD per kg in case of the coal gasification, and 4 USD per kg in case of solar hydrogen. Means it can drop from 2 to 1.4 and 7 to 4 USD per kg in case of solar. So that can only possible because of the enhancement of the advancement of the technology, right? We have to identify the where are the losses. Okay, so we can classify the hydrogen production from solar energy, right? So solar hydrogen production method can be classified into photochemical, this is photovoltaics, or thermochemical and electrochemical process. In photovoltaics, basically most of yeah, I have another 15 minutes. So solar energy, solar photovoltaic energy we can use for the photoelectrolysis process, photoelectrolysis of the water, and thermochemical process, the solar cracking of hydrocarbon, steam reforming of hydrocarbon, thermochemical transformation of the biomass. These three technology which gives some more advancement and more research as compared to this photoelectrolysis of water. This is very simple. Now it is quite mature technology. You need only the electricity you can use for the electrolysis of water, right? And this is another the electrochemical process. We can have discussion on this. Just see over there in the photochemical route, the solar energy, incoming solar energy. This is the in fact for solar photovoltaic, this solar radiation has a wide spectrum. So only we need the visible range of the energy, visible range of the solar radiation, that is the 0.38 to 0.78 micrometer, right? So this is only the useful for us for conversion of electricity, and the solar photovoltaic panel convert into the electricity, and some other devices are involved over there. However, I have connected directly with the electrolyzer, and the water is feeding over there, and with the help of electrolyzer, we can produce the hydrogen and oxygen, right? Yes. Okay. So this is a schematic process of the hydrogen production of PV unit. And in thermochemical process, and basically it include that for the hydrogen production is basically involved with the thermochemical cycle, direct thermolysis of water, solar cracking, gasification, reforming.
Anil said,
yeah,
it's not shared, sir. Screen is not shared.
Not shared.
Just now only it went. Just now.
Okay. Just a minute. Sorry for this interruption. Actually,
no problem.
Something.
Sir, no problem.
But actually, generally it works, but whenever you need, then only technology fails. Now, is it working?
Yes, sir. Yes, sir. Yes.
Sorry. Okay. So, so basically, in thermochemical process, in thermochemical process for the hydrogen production, these are some methods: the thermochemical cycle, direct thermolysis of water, solar cracking, gasification, reforming of hydrogen. And these methods basically need the high temperature, and high temperature we can produce with the help of concentrated solar radiation. So concentrated solar radiation, as I told, various conversion devices are there. The flat, there's this parabolic trough collector PTC is there. Then parabolic dish is there. Okay. Then this what is called this tower type solar energy conversion system, which is the halostatic. Many mirrors are over there. Mirrors are spread on the land, and they are focusing on certain point to create the high temperature. And in fact, we can easily achieve temperature in the range of the 700 to 800. The 700 to 800 degree temperature is our requirement for these process, thermochemical process, solar cracking, gasification. That temperature is more than enough for us for good. Okay. So and there is basically the endothermic reaction. So method depends on the solar concern and high temperature through the device, and endothermic reaction is there, and various kind of device that's solar. And now the sun is solar energy, or the radiations are converted into the falling on the concentrated solar energy system, and where high temperature heat is produced over there, and because of thermolysis, the water is supplying and thermolysis the hydrogen and oxygen. which is there. So decomposition of water for the hydrogen production during the operation of CSP. So depending on the different, despite of the different kind of the CSP system, they all depend on concentrated high using the 100 of mirrors. And in fact, as the concentration ratio is very important thing for the energy CSP system, the value of the concentration ratio is more that the high you can produce, you can able to produce the high and high temperature. So it is basically defined as this ratio of aperture area through which the solar radiation is coming or falling on that surface, and divided by the concentrated area, so or the absorbed surface area. Okay, so it can be the 1500, and roughly you can say if suppose the concentration ratio is 1500, you can easily be able to achieve the temperature of the 1300 to the 1400 degree centigrade. Okay, so in that sense, so and now the required heat energy is absorbed in order to as to production for the various CSP system. Okay, so solar tower, parabolic trough, and like this. So now in solar cracking, basically in the concentrated solar energy or the high temperature heat is applied to in the solar cracking system. And cracking we can do with the help of the catalyst and without catalyst also. So hydrocarbon, we are supplying over here the hydrocarbon. Okay, and see the solar thermal cracking of the hydrocarbon recognize the co-synthesize. This is co-synthesis process, and the black carbon, this is the byproduct, black carbon, and it is also useful for the many industry. Okay, so along with this hydrogen, so nothing is waste over there. Hydrogen production from the methane decomposition was started in the separation of methane was permitted in the 2100 Kelvin from the developed reactor, and method was again in 1999. So, and now this is basically the steam deforming process, right? So in steam deforming process, again this high temperature heat is applying to this feedstock, basically the feedstock such as the propane, butane, methanol, jet oil, diesel, naphtha. So we can produce the hydrogen with the help of these feedstock, and the reaction takes place with a very high pressure, 20 to 30 bar with the high temperature of the 840 to 950. So to achieve the temperature of 840 and 950, we can easily achieve with this temperature with the help of CSP system, right? And Marty has already performed the study of the propane reforming with the non-catalytic at a higher temperature using this solar reactor, and if suppose we are using the catalytic, definitely it enhances its rate of production, and this fast reaction is taking place over here. A thermometer perform experiment on the steam methane reforming operation through the solar reactor and attain the methane conversion approximately the 87% with the H2 molar fraction of this machine. So this is you can say it is quite efficient technology. And in fact, this is just look at over here this picture. This is the process of reforming process of the natural gas, means the methane. Basically, methane is reforming, and in natural gas the major constituent is the methane. First we do the sulfurization, and sulfurizing then natural gas is passed through this steam reformer over there. Then the gas separator. This is the gas separator after steam reforming. Gas separator is coming, and the temperature converter. Right, and finally, after condensation of gas, and gas is purified and it collected into the hydrogen storage system, right? And other byproduct is separated over there, and along with the natural gas again feed to the system. So this is not a very it is very successful technology, right? And here we are using the solar energy. Solar energy is utilizing completely over there. So and basically we need the heat energy. So the generation of temperature steam deformation, the 800 or 900 degrees centigrade, we can easily achieve that much of temperature, right? And in fact, this in thermochemical transformation of the biomass process, as we know that this process is again very simple. Like biomass is biomass which is constitute of biomass which is a constituent of cellulose, hemicellulose, and lignin. Okay, and it dry with the help of the solar heat, and again over there Actually, for the drying and for drying application, we can use the low temperature solar energy thermal technology. And this is these are the solar air heater flat plate collector. You can use very easily, and it can easily we can easily can achieve the temperature in the range of the around the 100 degrees centigrade. And if we want more temperature, we want to, like here, the drying at the higher temperature, so evaporative collector, we can freshener lens collectors we can use for the drying purpose. Then further this thermolysis is taking place with the high temperature over there, right? So in drying, basically the drying matter is the C6H4 and O3, then O4, and it is thermolysis is taking place at a very high temperature, 500 to 600 degrees temperature. So what is happening over there? Gas CO2 and plus this methane or hydrogen condensed liquid, water, methanol and acetic acid, acetone, and these then further converted to tar and the coal. Okay, in the gasification, after gasification, means thermolysis, after thermolysis at the high temperature, the gasification taking place, and further the solar heat is supplied for the gasification, right? In presence of oxygen, steam. Okay, so just look at over here, the electrolysis is taking place, the hydrogen and oxygen is there. Okay, so excess of the agitate and the excess of CO in extract from this process. Then further at high temperature, the solar heat at the 900 to 1100. So in the stage you can increase the temperature of the increase the temperature of heat source. Okay. And heat source is basically sun only, and the different technology are applying over here for the different to achieve the different temperature. So then the synthesis synthesized gas CO2, COS2, CH4 and O2 is there. The purification, synthesis and combustion is taking place. So this process is basically involved in the thermochemical transformation of biomass system, right? Biomass system. So this is also very again very means now mature technology. You can say this gasification, thermochemical transformation of biomass to hydrogen is very mature. Okay, so nothing is there. So now this electrochemical process is basically the Griffith et al. Review the electrolyzer PEM photon exchange membrane and show the various technology. The water electrolyzer found one of the electrolyzer PEM technology practically to produce pure hydrogen. Okay, and Agli have already established the graphical model in electrolyzer macroscopic and energetic nature. So main commercial advantage of the electrolytic hydrogen production are the stability and zero emission of the hydrogen. Okay, in the electrolysis process, in this process, electrochemical process. And now I would like to summarize this solar hydrogen production method. So efficiency, of course, efficiency is lesser. So efficiency of converting solar energy into electricity is a barrier to improving the overall efficiency of this. So this instead of converting electricity means for an electricity is needed for the electrolysis process, and we can better to use the direct heat which is produced by the solar energy only with the help of the solar energy conversion devices, CSP systems and all. So high temperature method require the additional material. Yeah. So that now in fact the material which can sustain at the high temperature, because that high temperature oxidation is occurred. Okay, so that is already developed, means technology is already developed, but it is means cost not cost effective, that we can say. So we can we can work out on this area also, the material development for the cost effective material development which can sustain at the very high temperature. Okay, so very for high temperature, definitely it is the focusing on the high temperature membrane, of course, and the heat exchanger for the solar process. And global solar hydrogen stream mainly consists of the solar hydrogen cylinder for transport and stationary application. And it is totally environmentally friendly production of the hydrogen using solar energy is very important for protecting the environment, since no greenhouse gas is generated during its operation. Again, I just want to highlight over here, during operation only I'm claiming the environmental, it is environmental friendly during its operation. However, for during the fabrication of the different energy, solar energy conversion system, whether this is solar photovoltaic module converting from the silica, raw silica to wafer, then solar cell. Okay, and then again the fabrication. A lot of chemical energy, a lot of energy is required. Okay, so whatever, whether the air, soil, water, all kinds of pollution is occurred during the fabrication of during the production of fabrication of solar cell from raw silicon, right? That silicon dust, and of course, as compared to this solar photovoltaic, solar thermal energy conversion device are less pollutant. We can say less pollutant because in their processing, see, for production of for the fabrication of the solar photovoltaic parabolic tuff collector, you need only some glazing surface, means reflecting surface, and we have very high quality of steel is there, which steel is having very high quality of reflectivity, and it can concentrate one for observer, or there's some tube, you need only the one observer tube, and where that absorptivity can be high as possible, and we have lot of selective coatings are over there already developed, and that we need to cover with the help of some glass, right? To reduce its convective and radiative losses, right? So that we can do very easily, and there is however, for during operation, we can claim that there is totally environmental friendly solar energy. So low exergy efficiency of photovoltaic generator, and hence the low overall energy efficiency for solar hydrogen system is currently challenging the research. So this is fine, as I have already discussed, like overall energy efficiency of solar photovoltaic system is still very low in real climatic condition, means real system in open environment. You just see, and otherwise in the lab skill level, people are claiming very high, and they always say no, it is more than 40 or 38%. They claim that 48%, 38% photovoltaic energy conversion efficiency is there, but in real sense it is not true. It is for the new system which is recently installed, it is having only the 10 to 11% of efficiency, and with time, and in fact its efficiencies get down, and many other factors are there with as the time pass, this glazing surface, this glass cover is having roughness is increased, and dust is also deposited. If suppose there is no maintenance, definitely it reduces the absorption of solar radiation, if suppose some dust deposition is there. So these are the some problems over there. So overall we can say the exergy efficiency of the solar photovoltaic generators are very low, right? So we have to identify and means we have to do first the exergy efficiency for component wise, okay, and then we have to identify in that component we have opportunity to enhance its exergy, okay, enhance its exergy efficiency in that way. So that we can do, and in fact many people are working on this itself. Numerous renewable energy sources have their own social or the environmental issue that need to be addressed. These obstacles are being actively addressed by the organization industry over. So so many people have already worked on the solar based hydrogen productions, okay, and sources just you see over here, concentrated solar power only, CSP, okay. So and worldwide, just you look at over there, this is Cameroon is an African country, okay, Turkey, China, Spain, Switzerland, India, and all over the globe. This solar hydrogen production, solar energy based hydrogen production is people are actively working on this. So look at just and see this efficiency, this thermochemical solar energy, the process is thermochemical and energy, and this is basically energy efficiency. It is not exergy. Okay. Exergy efficiency is not more than 2%, 4%. Okay, this is energy efficiency. Then electrolysis, and of course the electrolysis, the exergy, particularly that part of the system, the electrolysis part, exergy can be higher, but in the overall exergy is lower. Okay, thermochemical, the energy efficiency is 20%. In thermochemical, CUL, photocatalytic, the energy efficiency varies from 46 to this. And now just look at over here, the thermochemical electrolysis process. The efficiency is higher. Okay, in thermochemical electrolysis process, right? And in thermochemical is lesser, means energy efficiency is the 20 to 28. Like in that will, a lot of work has been occurred in the last 20 years or 2 decades in case of the solar hydrogen production system. Okay, so in India, of course, we have a lot of opportunity to produce the green hydrogen. The green hydrogen definitely will help to provide the sustainable solution for Indian transport sector. And our basically the transport fuel is major requirement, and in fact this is one of the major component for the environmental degradation also, right? So if we could able to do something in the Indian transport sector, the fuel we can means solar based, whether this is the green hydrogen or other kind of this fuel, we can utilize the solar energy and supply to the Indian transport sector will definitely be helpful. So this the energy and research institute TERI in short is in Gwalior or in Habitat Center in Delhi. Predicted the demand, the hydrogen will increase. Hydrogen will increase 6 metric ton to 28 metric ton by 2020 with the cost of renewable it fall from 50% by this. So we can have hope for the cost of production of hydrogen with the help of solar energy will reduce in near future. And so TERI claim about 80% of the hydrogen in India will produce from the renewables by 2050, because our government of India is taking a lot of initiative for promoting the hydrogen production from renewable energy sources. Under the Make in India program, the government has already fixed start the opportunity production of electrolyzer and the fuel cell, which will allow the capturing the large share of this market worldwide. So government of India have already a lot of incubation center or the entrepreneurs, they are trying to developing low cost electrolyzer and fuel cell. And many of the organizations like ISRO, Indian Space Research Organization, Indian Oil, Bharat Heavy Limited, and Tata Motors, they are actively working on the hydrogen fuel cell technology. And the ongoing development in the Indian government and public organization create a lot of opportunity to become a major player in the sector. Right. So in overall, these are the main benefit from the green hydrogen, okay, or the solar energy basically. So reduce the petroleum import of the energy security, decarbonization of transport sector, integration of renewable and the hydrogen production, address the climatic issues. Okay. So now just look at over here how this is the whole slide. Solar energy production is higher as compared to wind energy, and just you can replace this and forward the figure, and more than 40,000 megawatt is produced by the solar power, and 38,000 megawatt is from wind. Okay, like in bio then. So in the last 10 years, government of India have achieved target of the 25% of total installation from renewable energy. Right now, we are lagging behind in this the hydrogen refueling station, and we are having only two hydrogen refueling station. One in the NICE National Institute of the Solar Energy, and another one in Indian Oil R&D sector in the Faridabad. And look at over there in Japan, the initiative, and they have already developed developed this hydrogen refueling station. German means this directly reflect their technological advancement and their work in the area of the hydrogen application, right? Hydrogen application for the transport sector. So in China also, and United States, Germany, Japan, they are very much ahead with us. Okay, we have to do a lot of work in this direction. So okay, and like government of India have taken the sufficient initiatives, and they are keen interest for the green production of the green hydrogen, and they have set up a mission, the green that is called the National Green Hydrogen Mission, to become the major exporter of the hydrogen with an incentive plan of $2.11 billion. This basically this initiative is a strategic intervention of the green hydrogen transition program. Under this program, the SIGT, the two district mechanism was main is the manufacture of the electrolyzer, and our target is to produce to build a capacity of the 60 to 100 gigawatt capacity in India. Okay, this is good initiative, and in fact the good target, and I hope we will definitely we will achieve this target, and by this achieving this target, and our cost of the production of this hydrogen will definitely come down, and to produce the hydrogen, right? And this region capable of producing utilizing the large scale hydrogen will develop as a green hydrogen hub, and this strategic intervention for the green hydrogen transition program has 3 phases. Okay, in first phase, establish the policy and guideline for the initiate the pilot project up to in between the 22 to 24, and next phase is to bring down the manufacturing cost and promote the incentive for the large scale production and scale up the production of green hydrogen. Within 1 year we have to achieve this target, and third one is the focus on destination hydrogen application, right? So okay, so solar hydrogen production, just have a look on this, the energy and exergy efficiency. This dotted part is the exergy only. Okay, and this means energy exergy efficiency with respect to the solar radiation, and this 1000 is not possible. Okay, it means it is possible, but under the certain condition only the 1000 watt per meter square solar radiation is there. So this is the energy efficiency of solar radiation and conversion efficiency. Okay, and now just look at over here the overall efficiency. This is energy efficiency minimum and energy efficiency maximum, and this red part is basically solar thermal hydrogen production, and this PV hydrogen production is blue part, right? And it is lesser. The energy efficiency is lesser in case of the solar photovoltaic system, right? However, just look at over here, the exergy efficiency in case of thermal is lower than this is actual useful energy is lower than exergy in case of PV hydrogen. So there many things are associated. In actual, the leakage is a major problem in the solar CSP system. Leakage is there, so leakage of the steam. So actual in minimum value is higher, but on the other hand, the exergy efficiency at the maximum, in case of maximum efficiency is higher as compared to the solar thermal. So overall, we can say the solar thermal hydrogen production is much more preferable as compared to solar photovoltaic. This is the sustainability index. Just look at over here, the sustainability index over there. Okay, so this is for solar thermal sustainability index for the exergy efficiency of the solar thermal hydrogen production, and this is for the sustainability index for the energy efficiency for PV system. Okay, so sustainability index, this minimum again the higher for this solar photovoltaic, and in this case the maximum value is higher for solar thermal. So this is the sustainability index, and this I can conclude this. How much time I have, Dr. Vishnu? I think I should stop over here.
Yes, sir. Yes, sir.
So there are the two routes of the hydrogen production, namely the PV and solar thermal systems are studied. Okay, based on the energy efficiency or the sustainability index. That the case study present and the analysis evaluate the our. So energy efficiency of the concentrating collector is an important parameter to evaluate the energy efficiency of the solar thermal hydrogen production as it fluctuates with the intensity of solar radiations, right? So this minimum value was higher in case of the solar photovoltaic system. This is the one of the main factor. The solar radiations fluctuate with the time, right? So both the PV system, production system, environmental friendly. This is fine in during the operation. So energy efficiency and considering with the increasing the radiations. Okay, this is true. The energy efficiency of system is higher than the energy as expected. That we know. Energy efficiency is based on the first law of thermodynamics. However, the energy efficiency second law and actual useful energy we are basically considering over here. Okay, so solar, of course, the energy efficiency is more than the solar thermal hydrogen production system has higher sustainability because of the higher energy efficiency as compared to PV hydrogen production. So these slide having more many case study. I will provide the complete set to Dr. Vishnath. Okay, so many things are there to discuss, but I couldn't because of the time constraint. So solar study of the cracking of the methane for the hydrogen production for the using this concentrator. CFD modeling is there. A lot of scope is there for numerical analysis we can do with this system. And one of my student is working on the steam deforming. In fact, the solar energy application is steam deforming modeling. He is doing modeling only because reactor manufacturing we couldn't able to manufacture or fabricate that reactor, and he's a part-time fellow. Very soon you will find a good research paper based on the simulation modeling based on the steam deformation or based on the solar energy in International Journal of the Solar this hydrogen energy. So there are a lot of things. So this is technological advancement that we can do. This is very good system, and in fact the students who are interested, they can replicate such kind of system. So this is over there the sunlight concentrator. This is separate filter because you need only the visible range. So when other than visible range, creating the high temperature and that adverse on this efficiency of PV cell, the CH4 and water you can supply over there with this electricity is produced. Okay, no, sorry. Okay, so over there the electricity is producing the PV cell only. So over there you can use this reactor, the heat exchanger, and this all. And this is a PEM photon exchange membrane fuel cell is there. Okay, students can duplicate this simulation modeling of this such kind of work. Okay, so many other things are there to discuss, but I should stop over here, right? So, Dr. Vishnath or coordinators, over to you.
Yes, sir. Yes, sir. I think you can switch on your video, sir. Your video is.
Oh, sorry. Actually, because always it works, but today I don't know what happened.
Maybe there is some network issue in the middle. That's the reason.
Yeah.
So I request the participants to ask questions to the speaker. So thank you very much, sir, for your wonderful session. It's been so much interesting and a lot of depth of research that you are sharing with all the participants. So there is some question from Shankar Das. Sir, I just unmuted you. Sir, you can ask the question.
Yes.
Sir, thank you, sir, for nice presentation. Am I audible, sir?
Yes.
Your presentation was highly informative, and actually I also came to know about the production of hydrogen. I was actually not aware of this kind of things earlier. So the thing is that sir, solar system, if somebody is using for making hydrogen or production hydrogen, is it economical, sir?
Actually, if you are using solar photovoltaic system, for the electrolysis process. Definitely the cost is very high, right?
Yes, sir.
It is right now it is not economical. The cost is around the $7 per kg of hydrogen production with the help of
750 per kg.
so $7 7. Okay, so main thing is the exergy efficiency is very less. So if we could able to reduce the losses, and definitely on the other hand you can say if suppose leave it the cost as concerned with your environmental degradation. So during its operation, definitely it is very reliable, and you can in that sense you can say, okay, sometimes what happened, definitely in coming time the cost of production of the hydrogen from with the help of the solar, it will reduce, because as you know, I remember 10-15 years back the cost of installation of 1 megawatt plant with the solar photovoltaic 1 megawatt plant was 18 crore. Now it is reduced to 4 crore only, right? So cost is declined because of the technological advancement. So after some time, definitely the more and more technological advancement will be there, and the cost will reduce at the photovoltaic point of view. And so in solar thermal is in fact it is a very much mature technology, right? But there the storage and fluctuation is main problem, because sun is an intermittent source of energy. During night time you cannot produce, right? For that the storage system you have to design solar thermal storage, which can, and in this case for hydrogen production you need to have a temperature in the range of 500 to 800 degrees centigrade. Very high temperature is required. So to store that heat energy in this band, this means 500 to 800 degrees centigrade is really very challenging task. I'm not saying it is not possible. It is very challenging task, and you have to be very much careful while designing the storage system, and everything you have to take care very responsibly, right? So this is the problem. These are the facts basically. Yes, sir.
Sir, one more question, sir. Sir, this according to Terry, you told you have in one slide you have told that also it is coming under renewable comes under renewable energy. But sir, hydrogen you told that already it is coming from natural gas, fossil fuels. So how will be now renewable, sir?
Means like Terry means Terry is taking a lot of initiative for the solar based or the renewable in fact a renewable energy based hydrogen production, right? Actually, what was your question? I couldn't understand.
Actually, see, because the from natural gas generally your solar system is taking producing hydrogen by natural gas or fossil fuels. That is not renewable, that is non-renewable, I think. But how come we can make it renewable?
Currently, yes, Sankarji. Actually, right now the natural gas is being utilized. Of course, it is not a cost-effective technology. If you are producing the hydrogen with the help of the natural gas is fossil fuel, that we know. But like in natural gas, what is there? The CH4 constituent is major. So I mean to say the CH4 you can extract from the biogas. Okay, so you can utilize the
biogases,
biomass material for producing the CH4. Then
from biogas that will be definitely
yes. Okay. But again the cost is much higher in this technology. But only the cost constraint is there. Otherwise, it is very much eco-friendly technology, right? So because what is there, you can consider this, and biomass is the net zero emission eco-friendly or net zero emission renewable energy sources, right? Okay.
Yes, sir. Yeah. Okay, sir. Okay, thank you very much for nice answer, sir. Thank you.
Thank you, Shankar Das, sir. Thank you very much. Other participants, you have to ask questions to sir. There are almost 140 participants. So if anybody wants to ask question, raise your hand. I can unmute you, or you can type in the chat box. Please participate in the question answer session. There is one of our student also joined here. Do you want to ask anything, Mohit, to the speaker?
Good number of participants.
Yeah.
And it shows the success, basically success of your program.
Thank you, sir. Thank
Almost
you.
I could able to see 140 participants are there.
Yes, yes.
Generally, it is very difficult to get the participants now these days, because this is the this time the session is on. All the classes are started. Like in fact, the classes are on the peak because of the end of the session is very near.
Yes,
but
sir.
still the participants are here. It is happy to see.
So they are interested in this new topics related to hydrogen.
Yeah, the topic is
Yes,
very
yes.
interesting, and definitely the hydrogen and fuel cell. In fact, this is the future of.
Actually,
of
we have
energy,
got
basically.
an elective course for the final year students, sir.
Okay.
This topic. So that is the reason we have thought of putting short-term training program, so that students will also get benefited.
Right.
Two sections,
So
one section
definitely.
Jivitesh Panda sir is teaching, one section
Yes, sir.
IT.
Hello, sir. Sir, actually,
Hello.
we have
Yes, sir.
just before, just now we are in the process of writing one proposal, like for the
Yeah.
gasification process. Myself and Vishwanath sir will take the help
Yeah.
from you regarding the hydrogen production. Normally,
Yeah.
electrolysis process we are going to conduct for the production of hydrogen, but for the gasification, like from other sources like
Biomass.
CH4, like biomass. So regarding that, already we are in the same process, sir. Only some gasifier is required to justify how. So definitely we'll contact you, sir.
1 kilowatt of gasifier you can easily find in Gujarat. In one company is there, Ankur. Okay, and in very low cost. Cost is not much high. The small scale or the one just take the 1 kilowatt capacity of the this biomass gasifier, or in fact the steam reforming, the modeling and steam reformation. You can work out on the steam reformation also.
Okay.
Right. So modeling and this experimental validation, a small setup you can, even the small setup you can have in your laboratory also.
That is what we are thinking, sir. Actually, at least lab setup,
Yeah.
if it is there, no, we can do some experiments and do some research also.
Definitely.
Sir, one more question, sir. If we are going to produce from the methane for the hydrogen, so it will be green or blue, sir?
You are going to produce the methane from hydrogen.
Yes, like water electrolysis process.
No, sir. What he asked is to produce hydrogen from methane.
Yes.
Yeah.
Not methane from hydrogen. If you produce hydrogen from
one
methane,
thing is there.
Is it green or blue?
No. See, the basically the blue, gray, blue, green hydrogen decide based on your raw material. What raw material you have considered, right? And in fact, if suppose the natural gas, you are considering natural gas
Yes,
from the crude oil. Okay.
Sir.
So that is not green. If suppose you are considering methane from biogas, that is
yes.
green. Yes,
that is green. Yeah. Yes, correct.
So,
So definitely we need your like a large expertise in this same field.
No. Actually, I in fact, I am not expert. Okay, I know little bit about the solar thermal energy conversion.
Yes, sir. Yes, sir.
So on the from the last few years, 3-4 years only, I am just trying to get into this hydrogen production from solar energy. Just I'm trying to get some space in this area. I'm not expert. I'm just
Sir,
I'm a learner,
sir,
and in
you have lab,
fact,
sir.
No, actually, that's
yeah,
what that is what I wanted to share. Like, sir is an expert in solar.
Yes, sir.
I learned many things from sir, but hydrogen, I came to know recently only from sir. Maybe as he
okay.
said, doing from few
Sir,
years
sir,
back.
do you have a lab regarding the same, sir? Like
Yeah,
production technology?
actually, fact is this, here, after coming over here in a DTU, I
Sir,
have joined in 2018, very recently.
sir,
I'm just trying to develop, I'm at the same level as you, but I'm associated with the many institute, like
okay.
in Thailand, in India itself. My association is there with them, so I'm just trying to do some work with them itself. But
Actually,
I'm, yes,
sir,
uh,
sir, sir, please,
um,
please.
yeah, yes.
Sir, please continue, sir.
Yeah, so actually, however, I'm trying to work out on the hydrogen production itself, and some discussion is already started, and something is already been framed for hydrogen production with the help of the solar thermal system,
Sir,
not the
sir.
solar photovoltaic, because in solar photovoltaic there is nothing to do. Already solar photovoltaic technology is well established. Only you have to connect the different component, right?
Sir,
Over there. Main challenge is there to produce the high temperature, and that high temperature can sustain for the long time during the night time, during option sign hour, because, and this is main problem with this lower exergy. I show you that there are lower exergy in case of lower exergy in case of the solar thermal route of hydrogen production from the solar thermal route as compared to solar photovoltaic in minimum. So that minimum is higher in case of the solar photovoltaic, but minimum is lower in case of solar solar thermal for the hydrogen production, right? So this is because of this fluctuation, storage, and that's all problem. Storage at very high temperature.
yes, yes.
That is our requirement. However, on the other hand, the electricity supply is very uniform for the
Exactly.
electrolysis process. Electricity is there, right? So that is the thing.
Sir, the storage will be in the, yeah, sir.
Huh, the high
Sir, I asked
temperature
the store.
storage means salt
Yes, yes.
hydrate, halides are there, salts, right?
Sir,
So so very high temperature, that is only the most economical technology for the storage and the heat storage at very high temperature
Sir,
for some time.
you are using parabolic dish or collector to reach that
Yes.
temperature? Okay.
Yeah,
okay.
right now we are using the parabolic disk collector. We are using, but
Okay.
for attaining high temperature, definitely you require the mirror type, heliostatic type, tower type.
Heliostat. Yes.
Helostat.
That is the most promising for creating the high temperature in the range
Yes, yes,
of
sir.
500 to 800 degrees centigrade, right?
Okay, let us
Yes,
give
yes.
opportunity to Gopi Krishna, sir. I think he
Yes,
has
sir,
a
please.
question. I'm unmuting you, sir. Gopi Krishna, sir, you can talk to the speaker. I'm unmuting you. Okay. Yes, sir, please.
Sir, I have posted the question.
Yes,
Actually,
sir.
we are going to integrate our electrolyzer, AEM electrolyzer to solar PV.
Yeah.
Sir, can you please suggest to the what kind of connection we have to give to solar? Like, is it DC-DC converter? What will be the type of connection?
Actually, see, in solar photovoltaic system, the electricity production, many components are there. Solar photovoltaic module, okay, and in fact, to continue, what I suggest, better to have the grid connected system, solar photovoltaic, so that you are producing you can do the analysis in such a way, whatever energy is producing, you are directly feed into the grid system, right? And whenever is energy is required, you are taking from this is for the grid connected system. If in case of the remote area, definitely you would not have the grid connected system, and in there the you must have the complete system, like solar photovoltaic module. You need the solar charge controller, battery backup, right? Battery backup and this solar charge controller and inverter. Okay, so it is my suggestion to you, always try to take the AC current, AC current only instead of DC or other thing, because you have an option to choose the if suppose that this system is failed, then you can connect with the grid itself. And in fact, one more thing, the standalone system, if it is highly necessary, then it is fine. Okay, in the remote area, in tribal area, some medicines are you want to preserve, then it is okay. Otherwise, better to, if you are located in the urban area, better to locate better to have the grid connected system only. That is more reliable, more economical, because whatever, because of the net matter, you just use your supply you can have with from the grid connection only, and whatever you are developing or producing the energy, you are just directly feeding to the grid. Okay, so net metering system, smart metering systems are there, so such kind of the work is there. So so in electrolyzer, uh, uh, definitely PEM type is there, one option is there that you can choose. So in that sense, you can do the complete energy analysis of the system, embodied energy analysis of the system. Embodied energy is much more benefit, or much more reliable in terms of the gain, in terms of the real knowledge, basically. What happened, so better to have do the embodied energy based payback period, okay, instead of the economical payback period. So other, because value of money is keeps on changing, right? So embodied energy means whatever the energy input for the fabrication of such component, that component, and many kind of components are there. So until unless the technology change, and the energy investment or energy consumption will not change. So in that way, you can do these kind of application, right?
Are
So
you, sir?
Dr. Vishnathji, what
Yes,
is
sir.
next? What is next?
Actually, the next plan is there will be a short feedback forms which everybody has to fill, sir. That is
Yeah.
normal for all the sessions. But because today is the last date, along with the feedback forms, we also have assessment test,
Okay.
which every participant has to take the assessment test. I will circulate that forms in the chat box.
Mhm.
But before that, there is a validatory function in which our registrar sir would join, and we will invite him. That's what the original plan is, but he has not yet turned up. So I'm not sure if we have to just give me a few minutes, sir. I'll just
Oh,
confirm and get
yes,
back to you, sir.
yes.
Just
No
few
problem.
minutes.
I'm here.
Meanwhile, I'll post the feedback links in the chat box where participants can do it.
Yes, yes, yes.
Assessment, we'll post it later. Assessment test.
Yes, after completion of all the session, we post.
Sir, few minutes, sir. Give me a few minutes.
So, good afternoon, all participants. I would like to thank you all. This is HOD Mechanical Engineering, Anurag University, Chalapati. We will start the valedictory function in few minutes, maybe exactly in 6 to 10 minutes. Our registrar sir is going to join through online in 10 minutes. He is in another meeting, and maybe by 12:50 we will start the program. Thank you, and please stay online. Thank you.
Dear participants, don't leave the session. After the feedback form, after valedictory function, we'll have the assessment test. All of you required to be present to take the assessment test. Then we can wind up the session. There will be a valedictory function in 10 minutes. Meanwhile, you all fill the feedback forms. Thank you. If any participant would like to share their views about the short-term training program, we welcome them. We will unmute them. You can all express your expressions, I mean your words, through the speech. If anyone would like to do it, then please raise your hands. I'll unmute you. If anyone would like to express their views about this STTP program, please raise your hands. I'll unmute you. Thank you. कैसा पता चलेगा कौन है इसके? कैसा पता चलेगा? ओह, रिकॉग्नाइज कोई रेस नहीं कर रहा. Naresh sir, you can talk. Naresh sir?
Yeah.
Yes, please, sir.
Am I audible, sir?
Yes, sir. Yes, sir.
So it was well organized sessions, sir. The total overall STP was good. So we learned a lot during this STTP, and we got opportunity to get exposure about international research, what is going on in this fuel cell area.
Yes, sir.
Even we are able to get connected with them because of this STTP, because we don't know, right, who are the people working in this area. So it's a wonderful opportunity for us to interact with them during the sessions. And is there any chance of getting connected with them, sir?
Definitely, sir. Definitely. I will. I'll talk to them. Whoever would like, we can make a connection. That's not a problem, because ultimately it is meant for research and our academics. So definitely we will make you connect to them.
Yes, sir. Please,
but usually they do not have contact numbers. So the best way to connect to them is via LinkedIn.
Yes, sir. I will do that. But let us know whether they are happy to get connected with us.
Definitely, sir. Definitely. If anything you want, I have my email address. I can post it here.
Yeah, please, sir.
Or we have our common email STTP address email.
Okay.
So that also I can post in the chat box. If anyone would like to take this further for any R&D works, definitely you text me in the email. I will forward it to those speakers.
Okay, sir. Please share your email, sir. I will share.
Definitely, sir. Definitely. I'll share.
One more thing, sir. If any good STTP programs like this in future, please let us know.
Definitely, sir. Definitely, sir.
And also, we would like to have a continuation STTP of this fuel cells and hydrogen storage to learn further.
Thank you, sir. Thank you very much. Thank you, sir.
So overall, it was a well organized, sir. And
thanks a lot, sir.
If you can share the PPTs if they are sharing, so that will be more helpful.
Yes, I actually have a drive. I asked all the speakers to share the PPTs. Okay. I have received 2 of them right now. Okay. After this session closes, we will share that drive to all the participants, or we can directly email to you all these PPTs.
Yeah, please, sir. One more thing, sir. What will be the duration of this test? What you are saying now?
The assessment test will not take more than 20 minutes, sir. It will not take more than 20 minutes. It will have all the questions from all the sessions that are covered till today. Okay. So from each session, we will have 2 questions.
Okay, so like it is like a choice based or what? How it will
no, I'm telling, sir. There are almost 9 sessions. So 9 to 18. So we will be having 20 questions. And it will be completely multiple choice.
Okay.
So, but those who have heard the classes, or even if little bit general knowledge about these topics, they can easily write the exam.
Okay, sir. Because we are very new to this area. And that's
every one of us, sir, because this is a growing field. So
yes.
That is the reason we actually gave this STTP.
Actually, we are in the office now, and it's about lunch time. So if it can be done as soon as possible, it will be good. Actually.
Yes, sir. We'll do it, sir.
Okay, sir. Thank you very much.
Thank you, sir. Thank you. Shankar,
I'll be in touch with you, sir. I'll be in touch with you.
Sure, definitely, sir. You are from which college, sir?
I am from Bitspila, Hyderabad, sir.
Okay, definitely, sir. Definitely.
Right, sir.
Thank you. Thank you very much, sir. Shankar Das, sir.
Am I audible?
Yes, sir. Audible, sir.
Okay, sir. Sir, first of all, I would like to thank you very much, you and your institute and your team, to really organize such a wonderful program. And particularly, actually, when I got the message from Jivitesh is my PhD mate from IIT Agartala.
Yes, sir.
And I thought whether to join or not. And nowadays, in my amazing disaster, you might have listened about it. Okay. Anyhow, I am not suffered because we are in a separate place. I think the thing is that in spite of this difficulty, I attended the training. Maybe there are certain difficulties like connectivity, poor connectivity because internet problem is there. Still, then I enjoyed from the beginning from that Australia University, madam. Really, that was fully I've attended. Then second session was partially disturbed and like that. But daily, each and every session I am attending interestingly. And all sessions are actually highly informative. Actually, I'm a man of design. Still, this topic was interesting, and I found many things are informative related to fuel cells, hydrogen, these things. I think actually some related works in this area can be assigned to my students here as a project work. And in future, if I need any help, can I contact you and your team? And otherwise, your the guests who have joined. Is it possible, sir? In future,
definitely it is possible, sir. They are also eager to support us.
Yes, definitely.
They will definitely eager to support us because I got personal mails from them that if anybody is interested, they can contact them also. So it is very much possible, sir. Very much possible.
So similarly, master degree project, suppose I am getting from any student like this topic, okay, I can assign, and also in collaboration also it can be done because some co-guide like that to universities. Generally it is done, no, sir? And also, yes, is that me, sir?
Yeah. What that is possible, but I will have to cross check with them, sir.
Yes.
If they say that is fine, then we can go ahead, sir. There is no issue.
Definitely, sir. And moreover, sir, I actually, because of this poor connectivity and these things, I could not get all the time connected. So I want the recordings as well as PPT also.
Definitely. Recordings are available, sir, in the YouTube. Everybody can see it.
Okay,
I will share the links also, YouTube links in the group. Daily sessions, everything is recorded. PPTs, not all the speakers have shared because they said there are something confidential things which are not to be shared. So they will edit the PPTs and they will share it to me in time, in future. Then I can send to all your email IDs, sir.
Okay, sir. And sir, this participation certificate will be done today or afterwards, sir?
Participation certificate will take some time, sir, because the foreign university logo also needs to be kept on it. So it will take some time.
Any other assessment question type of things are there, sir, today?
It will be there, sir, in short time. Just 1 minute, sir. Our HOD, sir, would like to.
Okay, sir.
Sir.
Okay, nice, sir. So finally, sir, thanks a lot, sir. Really, I enjoyed it. Okay, thank you very much.
Thank you, sir. Thank you. Thank you.
So waiting for the registered sir to join. Soon registered sir will join, right? So by the time sir joins, let us start the valedictory function. So I request Anuya madam to start.
Okay, sir. Ladies and gentlemen, distinguished guests, and the accomplished individuals gathered here today. We have special individuals among us who deserve our heartfelt recognition. Dr. Balaji Utla sir, Registrar AU, Professor K.S. Chelapati sir, Head of the Department, Anurag Mechanical Department, Anurag University. As we draw this event to a close, let's take a moment to acknowledge the exceptional leadership and dedication of our Head of the Department, whose immeasurable support is the reason for the success of this international short-term training program. Professor K. Srinivasa Chelapati sir, in charge HOD, Mechanical Department, in charge Director, Foreign Relations Office, Anurag University. I request you to address the participants, sir.
Thank you, madam. So, dear participants, I would like to thank you all for registering and attending all these sessions for these 5 days in the International Short-Term Training Program on the recent advancements in the fuel cells and hydrogen storage. Of course, this the topics of fuel cells and hydrogen storage itself are very advanced, and I assure that you might have gained some knowledge, a good knowledge from the resource persons, especially from Professor Surbhi Sharma of Federation University Australia and Professor Jun Peng of Lincoln University of UK, and who both delivered the keynote addresses, and they have given insights about the fuel cells and then the hydrogen technologies. And we are very fortunate to draw the resource persons from various premier institutions like IITs, NITs, and the other institutions of national import, like Dr. Venkatramana and Kodan Raman sir, who have given a very good lecture on fuel cells and the impedance and spectroscopy of the fuel cells, and Dr. Santosh Kumar sir and Gaurav Gupta sir on the third day, where they dealt with the thermodynamics of the fuel cells and the other aspects of the fuel cells. And yesterday, Dr. Ram Naresh sir and Dr. Abhishek Paul sir both have given very good insights on the hydrogen storage systems and then the future of the hydrogen in the road transport. And today's session, Dr. Anil Kumar sir, even though there are some small network issues, but sir has given how the solar energy can be given or applied for the hydrogen storage or hydrogen production. Now, if you have seen the application of this, already the Toyota has started, Toyota Maria is there, has started the first hydrogen, fuel cell car. They produced and they already marketing. It is on the roads, and which is making its own fuel. So fuel cell is nothing but that. So making its own fuel, and it is going good. So from the point of research to the point of reality. So it has already started, and we could get soon the hydrogen powered or fuel cell powered cars on the road, if not in 1-2 years, by 2030. Even the EV may not be there, or EV may be reduced, and the companies will start working on the industry, the automobile industry will start working on the fuel cells. So I would like to thank all our resource persons for taking their time and giving valuable insights and good knowledge share among our participants regarding this our STT. And all these participants were patiently listening and getting the knowledge and interacting with the resource persons and gaining the knowledge and getting some insight about the fuel cell is a good start for us, and it has given us a good boost. And we are planning for an international conference for the next year with this support and enthusiastic participants. And on any day, if we see there were around 140 to 150 participants online every day for every session, and that makes us very proud that we got a very good response. Of course, there will be some network issues will be there every time, for one or the other, but that will be around 10%, and that can be considered, and definitely all those will be considered. Your requests are being considered, and we are taken care of. So I would like to thank on this in this regard, and I thank our organizing team, especially Dr. Jiptesh and Dr. Vishnath, for taking time and pains in organizing this wonderful event, and all our organizing team behind the screen, the Mr. Arun Reddy or Amresh or Srikanth or Sandeep, who are working behind the scene for making the online meeting in a proper, smooth way. I thank our management, Anurag University, for giving us this opportunity. I thank our Registrar Sir and the Dean SOE for supporting us and guiding us and how to in managing the thing and in moving the STTP in a better way. So I thank everyone, and over to Anurag. Please see whether Registrar Sir has come on.
Thank you, sir. Now it's my distinct honor to introduce a distinguished person who plays a pivotal role in our academic institution, who have joined us today. Dr. Balaji Utla sir, Registrar, Anurag University. Dr. Balaji Utla holds a doctorate in management. He has 36 years of experience spanning organizational strategy and development and corporate social responsibility and academics. He was CEO, Vice Chairman, and co-founder Priya Healthcare Private Limited. Before, was founder CEO of Piramal Swasthya, formerly HMRI, and President Corporate Sustainability at Piramal Healthcare Limited. He was involved in designing 108 emergency services and 104 health services. Dr. Balaji Utla sir was the founder, CEO of Satyam Foundation, initiated by Satyam Computer Services, now Mahindra Satyam. Under Dr. Balaji Utla sir's leadership, Satyam received the Corporate Citizen Award from FICCI in 2006 and TRI Award in 2007. He also worked as the head of corporate strategy at Satyam Computer Services Limited. He is a co-founder of Pennedy Foundation that provides job training for Dalit and tribal youth. He serves on the governing board of Anurag Group of Institutions since 2010. He has many publications to his credit and is a regular speaker at healthcare conferences in India and abroad. With great respect and admiration, I now invite Dr. Balaji Utla sir to share their wisdom and insights with us in today's session.
Thank you very much for that very generous introduction. In United Kingdom, they say they feed the pig very well before they butcher it. Anyway, thank you very much for this opportunity to be at the valedictory function and share a few thoughts and words with you. First of all, I must compliment the organizers for thinking of an appropriate topic like hydrogen as a fuel of the future. And all of us know all our countries are committed to see to it that the environment is appropriately managed and right kind of stewardship is is what, whether it is Kyoto or Paris or any agreements that we do. However, there are challenges and issues to be sorted out. While at the lab level, the technology seems to have been mastered. At the commercial level, companies like Toyota seems to have mastered it in terms of productionizing it. However, the whole supply chain issues, logistics, safety, and acceptance are important in the whole journey. While that is the journey of any new technology to emerge, I think hydrogen as an alternative solution or an additional solution to the electrification of transportation is something that is very exciting. And I'm a big votary for technology for development of the world, and especially countries like India, which are yet developing. We have to balance the need for growth because we have 1.4 billion people And we also have to ensure that they get jobs and the industry grows. The transition from agriculture economy to industrial economy and creating new jobs is a challenge. So therefore, I think while coal is the primary fuel that we use in terms of generating power, electrification in a way solves one problem of the cities, but transfers that burden to other areas where the electric power generation houses are there. I do hope the training and many of the cutting edge researchers have shared with almost 160 participants or 200 participants who registered was fruitful and useful. It must have excited many of you. There are issues in terms of storage. Very rightly, I think the topics were very relevant in terms of exploring what are the challenges that are there in storage. If one can figure out that part of the problem, fortunately for us, since already the hydrocarbons in terms of petroleum distribution network supply chains are already there, it's just matter of it becomes a matter of switching very easily to move on to that. So the switching costs can be reduced. So my invitation to all the researchers and people who are looking at hydrogen as an alternative fuel to look at multiple options. One thought that came to me, if transportation is a problem, we can easily look at this as an alternative fuel for in situ applications. Like, for example, institutions like ours, where sometimes whenever the power is off, we use diesel as a generator. So we can look at hydrogen as a fuel cell technology as a potential solution. And our mechanical department and our rest of the engineering school is very excited and exploring these possibilities. There's a very exciting future ahead. One of the responsibilities that we have as citizens of this globe, I think we have to cross over this narrow national boundaries and learn from each other globally, so that our children and grandchildren are left with a better world than what we got from our parents. So we are also part of the problem. So it is we have to be conscientious about it in terms of contributing. There are in system dynamics, we believe that things move very significantly in a non-linear fashion. I do hope the research that has been done already and the amount of support that is coming from the industry as an alternative technology to EVs and other applications that one can examine. And I compliment our team from Anurag who have worked very hard to make this happen. I also congratulate all those who participated and benefited from this. I must definitely put on record the resource persons who shared knowledge from all over. They say in Sanskrit, Vidya Nama Narasya Rupamadikam Prachanna Guptam Dhanam, Vidya Bhogakari Yashashukakari, Videsha Gamane, and so on and so forth. Basically, knowledge is something that increases by sharing rather than hoarding it. So I must thank all the resource persons for sharing knowledge with all our enthusiastic participants. I compliment Professor Chalpati and his team, and hope we'll do these things more often and at a larger scale and make it beneficial for everybody. Thank you very much. Good day.
Thank you, sir.
Thank you, sir. Thank you so much. Now I request Dr. P. Vishwanath, sir, Associate Professor, Department of Mechanical Engineering, Anurag University, whose dedication and hard work have made this training program a great success. So please address the participants.
Thank you, madam. Thank you very much. First of all, I would like to thank our management and our academic leadership, Dr. Utla Balaji, sir, our registrar, and our respected HOD, sir, Charpati, sir, for giving us this opportunity to conduct this event successfully. It's been really, as sir mentioned, it is a hard work from long time, because this has been actually planned last month, but it has been postponed because of the availability of the speakers. All over the world, we have collected the speakers. So that's the reason it got postponed. But we are happy that many of you have registered and also hanged on to the sessions all the time, irrespective of the lunch time. I'm seeing that a lot of people have joined the sessions every day, nearly 150. So I hope everybody has learned the basics and the also the research aspects related to the trending topics like fuel cells and hydrogen storage, especially in this 20th century. So I welcome all of you. I congratulate all of you for this sessions, and please give the assessment test, and please get us be in touch with all of us for our future endeavors like this, such kind of workshops. So now I would like to again request my co-coordinator, Dr. Jitesh Panda sir, to also address the gathering to share his views. Thank you very much. Thank you.
Namaste to all of you. So, respected Registrar sir and our management, I am thanking to our management and our dynamic HOD sir for giving this opportunity to conduct such type of program, because without his knowledge and path, we cannot complete this kind of program. So I'm from my heart, I am congratulating and thanking to our HOD Chalpati sir for giving the platform, and best and not the least, our keynote speaker. And because the reason is from the throughout the globe, we ask the people, and they without any asking question, and they joined for us. And my co-coordinator Dr. Vishwanath Kumar, and most and the last, the participation. Without you, we cannot successfully complete such kind of program. So definitely we'll committed for the future such kind of topic, new trendy topic will come with you, and we expect you will be also join same time in future also. So thanking you without wasting in time. So we'll share the assessment link with you. Kindly join the assessment test, and thank you all. Any query you can ask us, and we'll share us our email ID in the brochure also there, or now also we'll share our email ID. So any query regarding in future, kindly contact us. Feel free to contact us. Thank you all. We're sharing the yeah, ma'am. Please.
On behalf of Anurag University Mechanical Engineering Department and my behalf, it's a great honor and privilege to propose the vote of thanks. We are grateful to our management, Dr. Balaji Utla sir, Registrar, Anurag University, Dr. V. Vijay Kumar sir, Dean SOE, for the support in conducting this international short-term training program. I thank our guest, Dr. Anil Kumar sir, for sparing their precious time to make this program a great success. My heartfelt thanks to the conveners of this STTP program, Professor K. Srinivasa Chalapati sir, HOD, Mechanical Engineering, Anurag University, Dr. S. Madhu sir, Professor, Director, ACE, Anurag University, Dr. Sikindar Baba sir, Controller of Examinations, Anurag University. Now, I would like to take a moment to acknowledge each of the coordinators individually. Dr. P. Vishwanath Kumar sir, Associate Professor, Department of Mechanical Engineering, Anurag University, Dr. Jitesh Kumar Panda sir, Associate Professor, Department of Mechanical Engineering, Anurag University, Professor Surbhi Sharma ma'am, Hydrogen Technologies, Institute of Innovation, Science and Sustainability, Federation University. They have been the backbone of this program, ensuring that everything ran smoothly from registration process to the delivery of the sessions. My heartfelt thanks to our organizing committee, Dr. T. Krishnaya sir, Associate Professor, Department of Mechanical Engineering, Anurag University, Mr. G. Arun Reddy sir, Assistant Professor, Department of Mechanical, Anurag University, Mr. V. Srikant sir, Assistant Professor, Department of Mechanical Engineering, Anurag University, Mr. K. Sandeep Kumar sir, Assistant Professor, Department of Mechanical Engineering, Anurag University, Mr. H. Amaresh sir, Assistant Professor, Department of Mechanical Engineering, Anurag University. Their immense support in organizing the program has been commendable. Your efforts have made a lasting impact, and we are deeply thankful for all that you have done, sir. We are grateful to Dr. Madan Mohan Reddy sir, Associate Professor, Department of Mechanical Engineering, Anurag University, for his continuous technical support for this STTP. I would like to thank all the faculty, staff who directly or indirectly involved in making this event a great success. I thank all the participants for active participation throughout the 5 days of this international training program and making it a grand success. Thank you one and all.
Thank you very much, Madam, Anukya Madam. Indeed, we are thankful to you also for spending your lot of time and effort in
Thank
every
you, sir.
session, introducing to all the speakers and everybody wonderfully. Thank you so much. Thank you.
Thank you.
Now, participants, all of you, please stay back and complete the assessment test. I'm sharing the link in the chat box. Assessment test is must for all of you to finish to get your certificates. Don't miss the assessment test. Please complete the assessment test. The link is in the chat box. I hope all of you have attended, filled the feedback form also shared earlier.
The Zoom link will be open till 1 or 2 o'clock. And of course, once you start doing the assessment, there is no need of the Zoom, but still the Zoom link will be open and the assessment link will be keep on posting for every 5 minutes. Thank you.
Thank you, sir. Participant Zoom link will be open till 2 o'clock. All of you, please fill the form.
Dear all, who has completed the assessment, kindly you can leave the Zoom. Thank you.
Dear all participants, the Zoom link will be there till 2 o'clock. Please complete the assessment. Please complete the assessment.
Sir, please stop recording.